Okay, welcome back to Subnetting. This is part 4, where we're actually going to demonstrate how to use that little card you created in part 3 to your best advantage. I just have it written down on a piece of paper, but make sure that if you haven't looked at part 3 yet, go back to part 3 and create a little card with that work on it, because that's going to help you tremendously in doing these problems we have on the board. Okay? So let's start here. We want to subnet. Remember, the whole purpose of subnetting is to get more networks for the address that's been given to you. Here my ISP gave me an address of 192.168.16.0/24. /24 means first 3 bytes are my network, which are inviolate. I cannot touch that. Okay, so those 3 bytes I cannot touch. So where I have to do my work, where I have to create subnets, is in my 4th byte. There's 8 bits there. Now, I need 3 different networks. So how many of those bits am I going to have to steal from there in order to get 3 different networks? Take a minute, go back to your chart, look at the formula for finding the number of networks. Okay, the number of networks is 2 to some power, the power being the number of bits I'm going to take. In order to get 3, I've got to go all the way to 2 to the 2nd power. If you look at your little card you created, if you go to 4, bit positional value 4, because that's bigger than 3. 2's not, 4 is, go to bit positional value 4, and look above that, you'll see 2 to the 2nd power. That power is the number of bits I've got to steal. So I've got to take 2 bits out of here. By taking 2 bits out of there, I can have 4 different networks. Now, also by taking 2 bits out of there, my prefix has jumped to 26. So, no other restrictions involved. I just want 3 networks. They can all be the same size. My first network, 192.168.16.0/26. Now I need to know how big these networks are, how many hosts I can have in these networks, so that I can find my next network. If you go to /26 on your little card, you'll notice it's part of the 4th byte. If you go up from there to bit positional value, you'll see 64. 64 is going to be the size of my networks. So if that's the case, my next network is going to be 192.168.16.64/26. There's still 64. I haven't changed anything. /26, still 64, so I'm going to add 64 to that. 192.168.16.128/26. I've got 3 networks that I can use based on the 1 network given to me by my ISP. Okay, let's see how that works in the 3rd byte. Here my ISP gave me an address of 172.16.32.0/19. Well, as soon as you see the 19, you know you're going to be working in the 3rd byte. This is the byte that has interest to us. This byte is not 0. This byte has a 32 in there. So if I write it out, that's what that byte looks like. Yeah, with the /19, that means I'm taking 19 bits from my network, which I cannot touch. The first 19 bits are these 16 plus 3 here. 1, 2, 3. So you'll notice I cannot touch 172.16. This is bit position 32. I cannot touch that. I cannot change anything here up. So the only things I can change are down. I need 6 networks. Okay, come up here. Bit positional value 4 is not going to cut it like it did. Well, then it did over here. Bit positional value 4 is not going to cut it. Bit positional value 8. That'll give me 6 networks. That's 2 to the 3rd power. So I need 3 bits. So if I'm adding 3 bits here, I'm going to have /22. Okay? I'm not giving any other restrictions. I'm not saying I need so many hosts. I'm just saying I need 6 networks. So my first network, obviously I can use that, 172.16.32.0/22. Okay? This means I can make subnets. This I cannot change. Okay? My 32 is still there. Now, 22. If we come into your little chart and you find /22, you'll notice it's in the 3rd byte and the bit positional value is 4. That means my network sizes are going to be 4. So I'm going to add 4 to the 3rd byte because that's where I'm in. My next network will be 172.16, 32 plus 4, 36.0, 172.16.40.0, 172.16.44.0, 172.16.48.0. And the reason I keep adding 4 is because these are all /22. I don't have to create variable sizes. I can just leave my /22 there, and /22 is 4. Bit positional value 4. So I've got 1, 2, 3, 4, 5. I need 6. 172.16.52.0/22. I've now got 6 networks that I can use based on that one address given to me by my ISP. I have not changed the ISP's address at all. And we can prove that easily. Let's take a look at 44 here. 44, the 8 bits. There's my 32. I've got 12 left over. Okay, there's 44. I'm taking 3 bits that I can't change. There's my 32. So I have not changed the ISP's 32, but I've added some numbers, and I said, okay, by the way, my network address is now 32 plus this 12, 44, and I'm using a prefix of 22. Now, if you look downward from this /22, you'll notice your subnet mask is 252. Okay, that's in the 3rd byte. So my subnet mask with a 22 prefix is going to be 255.255.252.0. We don't do anything with the 4th byte. We're working in the 3rd byte. There's my subnet mask. By the way, my subnet mask over here, /26. If you find /26, you'll notice it's in the 4th byte. The subnet mask number says 192. So it's 255.255.255.192. That's in the 4th byte. That's my subnet mask that corresponds to /26. That's my subnet mask that corresponds to /22. You can get that all very quickly from this little chart. Notice how fast we could figure out networking or subnetting using your little chart. Okay? When we get to part 5, we're going to actually look at using variable length subnet masking.